Okay, so we're doing 2.2 arithmetic combinations of functions. Do you all remember what function notation is? If I have this y equals 2x plus 3, how do I rewrite that using function notation? Yeah, f of x and everything else is the same. And what is this function? If we were to graph it out, what type of function? Linear, good. And if we look at this one and we rewrite this, f of x equals x squared minus 4. And what is that if we were to graph it out? That's a parabola, right? It's a quadratic equation. It would look like a parabola. Okay, so those are the two functions. And does that feel like review? Grade 10, maybe grade 11, and now we're looking at it. Okay, so then here's what we do with that. Basically, if it says f plus g of x, we can just do them separately. F of x plus g of x. And it's just a simple matter of substitution. So we can do 2x plus 3 plus x squared minus 4. And then we just clean things up a little bit. So when we look at this, we can see or notice that we have a plus 3 and a minus 4, so we could combine those. And we can rewrite this in descending order. Do you remember that? Descending order? Yeah, so we start with the x squared first, plus 2x, and then when we put these two together, we end up with a minus 1. So our answer, when we clean things up, ends up looking like that. Is that okay so far? Well, look at the next one. I feel like I'm kind of done with the teaching part. Am I right that you could probably figure out intuitively what to do with the next one based on what we just did with this one? Okay, we'll run through it together anyhow. But it's the same thing, only this time separated with a minus sign. So I've purposely chosen to use the same functions again, f of x and g of x. And we just take them, substitute, and subtract them. So 2x plus 3. This is important. We need to put brackets here because when we go to subtract this x squared minus 4, do you see that we would distribute that negative to both of those? And if we forget those brackets and forget to do that, it's going to change the overall outcome, right? So, and can you see the potential? So many people forget little things like that, and it just hurts when you get back and work and you see that you got that wrong or you missed out on it. It's not a big deal, but if we get into good habits of, like the little arrows, whatever helps you to keep organized, I feel like organization is half of this. So when we work our way through this, in the next step, we'd have 2x plus 3. This ends up being minus x squared, and this ends up being plus 4. So it's similar to the last one, but when we put this all together, instead I'm going to have a negative x squared plus 2x, and these two end up adding to give me plus 7. So instead I get this as my cleaned up equation. So far so good? I won't always fly through things, but I do feel like this one is sort of repetitive, the same ideas or same concepts. So, but you let me know if we need to slow things down a little bit. If we have this, we can again just rewrite it to be f of x, and this time it would be times g of x. Again, we're going to use the same functions that we initially labeled f of x, g of x. So for this, we would just use our 2x plus 3, and our g of x was our x squared minus 4. And we would go through, oh, except I used the wrong color. Sorry, everybody. Let me fix that. X squared minus 4. And in the next step, we will use the blue. When we multiply these, 2x cubed when we multiply these. Minus 8x. Then I go to my inside terms last, so plus 3x squared. And when I multiply those, we get minus 12. Are we okay with that? We want to, again, it's fine if you leave it like that, but we like to get into the habit of putting it in descending order. So 2x cubed plus 3x squared minus 8x minus 12. And that's how we would deal with this. We did adding, we did subtracting, we did multiplying. So of course next we're doing quotient or dividing. And you can see it's the same old thing. So our f of x was our 2x plus 3, and our g of x was the x squared minus 4. The only thing that's unique maybe or a little bit different with the quotient is we'd want to look at the bottom and see, is there anything that we could do to simplify, sorry, not just the bottom, I guess you'd look at both, top and bottom, but you'd look at it and think, if I were to factor, would anything cancel out in this case? No. Could we factor the bottom? Do you recognize it's a difference of squares? So if we factored it, what would that end up being? Yeah, x plus 2, x minus 2, right? But when I look at the top, there's neither one of those things up there. So it wouldn't allow me to cancel anything. So there's not much point in me factoring. I can leave it this way because the factoring isn't going to make anything easier. So why do that? It's not going to be wrong if you do, but you can leave it like this and it would be fine. Okay? You practiced yesterday or learned about domain. If we were to analyze the top here, what would be the domain just of the green part at the top? All real numbers. Everyone's good with that? And what would be the domain of the bottom? All real numbers. So when you're deciding the domain of the new function, so by new function, I mean this whole thing that we just came up with, we'd have to look at the old two functions that were combined to make it. And we also have to look at the new function that's created. So this quotient, are there any restrictions on this when we're talking about domain? Yeah. Everybody get that? If one of my functions, like if I change these and I made f of x like 1 over x, but the final answer ended up being like a linear function, for example, I still would have to say x cannot be 0 because of that initial 1 over x. Does that make sense? So you have to look at the domain of the initial two functions and the new one, and you have to find a domain that meets all the restrictions for all three of those things. Okay? I think, oh, see, I have a habit of doing this. That's basically what I'm saying here in a much messier, longer way. So if you want to rephrase that or write it differently, you're welcome to do that. Or if you feel like you don't need that because you got it, then you don't have to write it down. I'll read it to you because I feel like my writing's especially bad. When two functions, f of x, it's okay, I'll even color code them, f of x and g of x are added, subtracted, multiplied, or divided, the domain of the new function, I think I usually did the new function in blue, is the set of values of x that are common to the domain of f of x and g of x. So it's just a different way of saying exactly what we just finished talking about. So you'd want to look at the domain of the original ones that you started with. If there's any restrictions, you need to include those in the answer at the end. And then you also look at your end result. Okay? Do we still need a minute? Yeah? Okay. Okay, so let's look at some examples where we actually can find a numerical answer. Given f of x equals 2x plus 3 and k of x equals x squared minus 2x plus 1, find f of k of 3. There's different ways we can do this. But math is about patterns and efficiency and basically simplifying to take shortcuts and find a quick, easy answer. So, although there's different ways we can do this, want to take the easiest route? Okay, so if we want to look at this and take the easiest route, let's go through this. If we have f of x equals this and k of x equals this, then do you see that this would be f of 3 times k of 3? If you ever feel overwhelmed, or like for example the next one coming up, when there's tons of things there and you feel like it's difficult or confusing, I encourage you to live in denial and just hide half of it and pretend it's not happening. So let me show you what I mean. You know how we're doing f of 3? Let's just do that part first. So just f of 3, we're going to pretend the other part's not happening, is going to be 2 times 3 plus 3. Good so far? I'll put that in brackets so we know. And what's the answer when we do that? We just get 9, so that's pretty easy, not too difficult, right? So this is okay in math or in life, as long as you only do that temporarily, and then you bring back reality. So you just basically take a step-by-step approach. And now we can do the same thing with this k of 3. So we could say times 3 squared minus 2 times 3 plus 1. And if you take that sort of separate step-by-step approach and then bring them together, it's not so bad. And can you work your way through that? What do we end up getting here? Yeah, we get times 4. So yeah, there was a lot of stuff going on, but after working our way through this, what's the answer? It's just a nice simple 36. Questions, comments, or is anything unclear that you need me to clear up? It's okay so far? And feels a little bit like review, but with a bit of new stuff in there? Okay. We're going to be repeating it quite a bit, so hopefully that repetition will help if you're having a hard time with it. And again, also if you are struggling with it, you could even watch the YouTube video afterwards for help as well, right? Or beforehand, because some of them are already up. Yes? Oh, in like 15 minutes? Yeah. Good? Okay, so then this is the only thing that can happen with this. It's the same thing, but there's way more stuff happening, right? So now we have f of x, we have g of x, we have, the hardest part is the colors, we have h of x, oh wait, see, I messed it up, h of x, and we have k of x. So instead of just the 2 functions we've been working with, we now have 4 different functions to keep track of. No big deal. If we take that simple step-by-step approach, I think you'll find it's not too bad. So let's first just do this first portion here. I'll bring it back in a second, but I'm going to show you the same old, oh boy, forget that. Let's go to just this part, f of k of 1. I know you can't see it right now. I'll bring it back in just a moment. So our f of 1 would be, sorry, I'm going to take that away, just 2 times 1 plus 1. Times our k of x is equal to 2. What does it mean when the whole thing is just equal to 2 and there's no x or anything there? It's a constant. So what am I going to multiply all this by? Just the number 2. Does that make sense to everybody? So even though this thing says k of 1, well, I don't have anywhere to plug the 1 into. So I'm just multiplying by 2, this 2 here, because our whole function is just a constant. Are we good with that so far? Okay, let's still just ignore the other part. Working our way through this, what does this work out to when we combine them or put them together? This is just 3, it's going to be 6, right? So the whole thing there works out to be 6. And then we'll bring back the other part here. We had this minus sign in between, so I'm going to put the minus sign in between, and then let's go to this part. H of 2 times G of 2 is what we're working with, right? But we need a big set of brackets to make sure that we keep things straight and we don't forget something. So, H of 2, what's that going to give us? Yeah, so H was x cubed, so it's going to be 2 cubed, right? Times G of 2? Yeah, let's plug it in here. So it's going to be times 2 squared minus 2 times 2 plus 1. So the whole thing just ends up being 1. Do you see this just ends up giving us 6 minus, well, that all cancels and leaves us with a 1. So it's just 1 times 8. So this is going to be 8. So we got negative 2. Questions? Are we okay with this? Okay. Last thing. Given this graph of f of x and g of x, let's graph f of x minus g of x. I'm going to say this is our f of x, the top one here. I'll go over it like this if I can. Any ideas how we do that? We did it using equations in algebra. How do we do that using a graph? Yeah, we basically just want to subtract the y values, right? So, my voice is going. This is odd. Let's say right here, f of x, what do you think that f of x value is? That looks like 3, right? So we would take our, oh, I didn't want that, our value of 3, and we would subtract what looks like 5.5. What do we end up with? Around negative 2.5. So it's actually going to be off the graph here, but I'm just going to try to plot it at the bottom there. What about here? If they're crossing, what's my new y value? 0. I'm subtracting them, right? So I know that my new y value here is going to be 0. Then I want to go to another point where it looks like they're right on a whole number. What do I get when I subtract f of x minus g of x there? Do you see it'd be 6 minus 4? So I'd get a value at 2. Do you get the process or the idea of where I'm getting this from? This is why the colors help me. We just have to remember to choose the green one first, right? Then here, I'm going to get rid of that. If we have this minus this, what do we get? What's our new y value? Yeah, it's going to be here at 5. Everybody good with that? I'm going to subtract these. If we go to here and here, what do we get when we subtract those? We get 4. So do you get the idea? We can keep going. Let's say we pick, I'm going to get rid of those because I was just using it along the way. But let's say I pick here and here. What do I get when I subtract those? I think that's at 6 and that's at 3. Yeah, so we get a 3 right here, which is exactly where it was. Good? If I select, I'm going to get rid of that. If I select, let's say here, oh, that's not the ideal scenario. Let's say that and that. What do we end up getting? 4. So here I'm going to plot it at 4. And we're starting to get a sense, kind of what this would look like, right? So we have something that's sort of going up that way. It's sort of headed down this way. For any of them where we're not sure, like here, what would we get here? What would it be? Wouldn't it be 5 minus, yeah, it's going to be at 2, right? So we go to here, and if we're unsure here, we would subtract again. We end up getting basically something that's looking kind of like this. And let's check the last one, 10 up here, and we have 1 here, so it'd be at around 9. So we're getting something that's looking like this somewhat. I could have done it much nicer, but do we get the idea, the skill of subtracting the y values? And the key is keeping track using colors or using whatever method helps you. And there's your assignment for the day.